Myself, Motika Srinivas. I'm working as an assistant professor in Department of Chemistry, Sundarao Swanke Mahavidyalaya, Mazalgaon. It is located in Maharashtra, India. So, in this part 1 of the video, we will cover postulates of kinetic theory of gases, deduction of gas laws, Boyle's laws, Charles law, Graham's law of diffusion, Avogadro's hypothesis. And remaining part of the lesson we will cover in part 2 of the video. Now we'll discuss the first point, postulates of kinetic theory of gases. The postulates are nothing but the properties of gases. Kinetic molecular theory is based on certain postulates. For example, a gas consists of a large number of minute particles. They are called as molecules. The molecules are so small that their actual volume is negligible as compared to the total volume occupied by the gas. The molecules are always in a state of constant rapid motion in all possible directions. They are colliding in random manner with one another and with the walls of the vessel. The molecular collisions are perfectly elastic, so that there is no net loss of energy when gas molecules collide with one another or against the walls of the vessel. The kinetic energy may be transferred from one molecule to another, but it is not converted into any other form of energy, such as heat. There are no attractive forces between gas molecules or between molecules and the walls of the vessel in which the gas is contained. The molecules move completely independent of one another. The laws of classical mechanics are applicable in the motion of gaseous molecules. The pressure of a gas is due to the bombardment of these gaseous molecules on the walls of the vessel. You can see here the gas molecules are moving continuously, and during their movement they are colliding on one another, and at the same time they are colliding on the walls of the container. So during these collisions on the walls of the container, they exert pressure on the walls of the container. The postulates of kinetic theory of gases, they can be summarized mathematically by equation, and this equation is called as kinetic gas equation, which is given as PV is equal to 1 by 3 M.Sc square, where P is the pressure of the gas, V is volume of gas, small m is mass of each gas molecule, capital N is equal to total number of gas molecules, and capital C is equal to velocity of gas molecules. Now, using this kinetic gas equation, we will deduce different gas laws like Boyle's law, Charles law, Graham's law of diffusion, and Avogadro's hypothesis. So first we will see what is Boyle's law. Boyle's law states that for a given mass of gas, pressure is inversely proportional to volume at constant temperature, or alternatively it can be stated as PV is constant at constant temperature. Boyle's law can be well understood from this diagram. If you look at this picture, a certain amount of gas, a gas having certain mass, is enclosed in this cylinder, and this cylinder is covered with a piston which are having certain weights. The number of weights is equal to the amount of pressure that can be exerted on this gas. So if we increase the pressure by increasing the number of weights, the piston will move in the downward direction and volume of the gas will decrease. Means if we increase the pressure, volume will decrease. Thus it can be stated pressure is inversely proportional to volume. But this is possible only if the temperature is kept constant. Now to understand why the temperature is to be kept constant, we will increase the temperature. So if we increase the temperature, even after increasing the pressure, the volume of the gas, it will not decrease because of this heating, the gas molecules will continuously collide on each other and their kinetic energy will increase. As a result, the gas will undergo expansion and the piston will move in the upward direction. So whatever the amount of pressure we are exerting on the gas to compress the gas, it is nullified by increase in temperature. So therefore, to prove the Boyle's law, it is essential to keep temperature as constant. We can deduce this Boyle's law mathematically by using kinetic gas equation PV is equal to 1 by 3 M.Sc square. So now this PV we will write as it is. So to this equation we will multiply by a number 2 and divide by a number 2. So there will be no change in this equation. Now after this equation we will replace this 2 and 3. So multiplication will be constant. Now this 2 by 3 is constant and this 1 by 2 M.Sc square, this is equal to mean kinetic energy. And this mean kinetic energy, it depends on temperature of the gas. Means if the temperature of the gas is constant, mean kinetic energy of the gas also remains constant. Now to the left side of the equation is PV. So we'll write this PV as it is. To the right side of the equation, it will become constant when the temperature is kept constant. So this PV is equal to constant. If we consider more kinds of gases, P1 V1 for one kind of gas, it will be equivalent to P2 V2 for second kind of gas. So likewise, it will be equivalent when for all the gases when the temperature is kept constant. Thus, Boyle's law is proved mathematically, and we have deduced this Boyle's law from the kinetic gas equation PV is equal to 1 by 3 M.Sc square. Now we will see what is Charles' law. According to Charles' law, the volume of a gas is directly proportional to its absolute temperature, assuming the quantity of gas and pressure remains constant. Now it is very simple. You can see here, if we increase the temperature of the gas, then volume of the gas will also increase. Again, this Charles' law can be well understood from the same diagram. So look at this picture here. We have to keep pressure as constant and the amount of gas also constant. So if we heat the gas, means if we raise the temperature, the piston will move in the upward direction because the gaseous molecules will undergo collision and the gas will undergo expansion, resulting in the upward movement of the piston. So if we increase the temperature, volume will also increase, and if we decrease the temperature, the gas will undergo compression and the volume of the gas will also decrease. So at constant pressure, the volume of a given mass of gas varies directly as the absolute temperature. Thus, this is called as Charles' law. Now we will mathematically deduce the Charles' law by using kinetic gas equation. So this is kinetic gas equation. PV is equal to 1 by 3 M.Sc square. So this PV is equal to, as usual, we will multiply this number by 2 to the numerator and to the denominator, and as we did previously we will replace this 2 and 3, so there will be no change in the value of the equation. Now this equation, it becomes like this, equation number 1. Now if we take a definite quantity of gas, then n is equal to constant. So this n is equal to constant, and at constant pressure, to the left side we will write this V as it is. So this has become constant. This n is also constant. So what is remaining is 1 by 2 mc square. So this is 1 by 2 mc square. So this quantity 1 by 2 mc square, it is nothing but mean kinetic energy per molecule, which varies with the temperature. Means if we increase the temperature, mean kinetic energy will increase. If we decrease the temperature, mean kinetic energy of the gas will decrease. So this V is directly proportional to absolute temperature. But this is possible only if the pressure is kept constant. Thus, we have deduced mathematically Charles' law by using kinetic gas equation. After this, we will see what is Graham's law of diffusion. So the Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of the density of the gas at constant pressure. Now see here, what is the meaning of diffusion of gases? At high concentration, the gas molecules, they are very close, but for longer time they do not remain very close. The gas molecules, they get diffused, so they move from that place to another place. So this movement from one place to another is called as diffusion of the gases. So the gas molecules, they are trying to be far away from each other, and this diffusion of gases, it depends on the density of the gas. Now mathematically we will deduce this Graham's law of diffusion by using kinetic gas equation. PV is equal to 1 by 3 M.Sc square. So see here, this PV is equal to 1 by 3 M.Sc square. Now keep this c square at one side, take all the terms to the other side. So this 3 in the denominator, it will come to the numerator, the equation will become 3PV. Mn, it is in the multiplication, to the other side when it goes, it will go to the denominator, so it is divided by Mn. So this is c square. If you take the square root of it, it is equivalent to c, equal to, so you have to write under root 3PV divided by Mn. Now from this equation you can see here, this Mn divided by V, this Mn is nothing but total mass of the gas, capital M, divided by V is volume of the gas. So mass divided by volume is equal to density of the gas. So here mass Mn divided by volume V. So this is equal to density of the gas. So you have to write 3P divided by rho. So this equation, it becomes C equal to under root 3P by rho. Now we know that the rate of diffusion R of a gas, it depends on mean velocity of its molecules. If the velocity of its molecule is higher, the rate of diffusion will also be higher. So this rate of diffusion is proportional to mean velocity, and this C is nothing but under root of 3P by rho. So therefore R is proportional to 3P by rho under root. So this R is proportional to this 3 is constant and pressure is also kept constant. So what the remaining terms are 1 by rho, it is under root. So Graham's law is proved. The rate of diffusion of gas is inversely proportional to the square root of the density of the gas at constant pressure. So we have deduced this Graham's law from kinetic gas equation. PV is equal to 1 by 3 Mn(c) square. Now we will deduce the last point, Avogadro's hypothesis. So according to Avogadro's hypothesis, equal volumes of all gases under same conditions of temperature and pressure contain equal number of molecules. Means if we consider here three kinds of gases, helium, nitrogen and methane. If their volumes are equivalent and they are under same pressure and same temperature, then the number of molecules for all the gases, they are same. So 6.02 into 10 to the power 23, same number of molecules for nitrogen and same number of molecules for methane. So this is called as Avogadro's hypothesis. So according to Avogadro's hypothesis, if volume, pressure and temperature for any number of gases is same, then the number of gas molecules for all those gases is also same. Now we will deduce Avogadro's hypothesis by using kinetic gas equation. For the sake of understanding, we will consider two kinds of gases, gas 1 and gas 2. Now this kinetic gas equation PV is equal to 1 by 3 Mn(c) square. It will become like this for gas 1 and it will be like this for gas 2. Now what we did, as we did previously, we have multiplied by the same number 2 and 2 and we have replaced 2 and 3. So the equations they will become like this. Now, according to Avogadro's hypothesis, when pressures and volumes of the two gases are same, then P1 will be equal to P2 and V1 will be equal to V2. So automatically their multiplications will also be equal. So the left hand side of the two equations will be equivalent. Therefore, right hand side of the two equations will also become equivalent. So see here, right hand side of the two equations is same. Now here, if the temperature of the two gases is same, then mean kinetic energy of the gas will also be same. Why? Because mean kinetic energy, it depends on temperature. As we are keeping temperature as constant, mean kinetic energy of the two gases will also become constant. So what is mean kinetic energy? Half mc square. So this is for gas 1 and this is for gas 2. Now if you look at this equation 1 and equation 2, this half mcc square and this half m2c2 square, you can subtract it from the equation 1. So what it remains is N1 is equal to N2. So this is called as Avogadro's hypothesis. Means if pressure, volume and temperature for two gases they are same, then the number of gas molecules for the two gases will be equivalent. So we have deduced Avogadro's hypothesis by using kinetic gas equation PV is equal to 1 by 3 mnc square.